Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I will help get you started, or continue, with Class 6 on plotting univariate data. Last time we looked at plotting categorical data. Now we will look at plotting numeric data. In the next video, we will code missing values and label factor levels. So we'll go down to the timetable. Class 6. And there's no specific R Markdown file here, which means that we continue working in the outline file. So we'll open up RStudio and open the document that we were just working on. I'm going to make changes to a document that I know is working, so I'm going to save it as a new file name. It's still the 31st of August, so I'm going to append a letter to it, and we'll keep going. Every time I switch windows, it's weird. This little RStudio window shifts over. All right, let's go down to find Class 6. Okay. So last time we made a bar plot for the categorical data, and we interpreted that. Now we're going to focus on plotting a numerical variable, and we'll look at some examples in the my example project on the website, and we'll choose which variable to plot and how we're going to plot it. So I'm going to go back to the website. I'm going to scroll up above the timetable to these files here. Let's look at this HTML. Control click will open that in a new tab, and we will scroll down to where we plot numeric variables. All right, let's see what some of the options are here. Now we're going to, in this class, almost exclusively use ggplot to create plots, but I just want to show you that sometimes it's nice to be able to just create a very quick plot. So here we've got a numeric variable. Let me make this a little bit smaller. When I zoom in and out, it usually shifts the screen a little bit. Okay. So zoomed out so I can see the hist function, hist for short for histogram. There's the data set, _sub. $sign indicates that I'm going to specify a column, and here's total cigarettes smoked. And I'm creating a histogram of that data, of the data in that column. And it makes a nice, quick, simple histogram. I can see that nearly all the values are sort of from 0 to possibly up to about 600. All right, let's create that same variable or the same plot in ggplot. And you can see it takes several more lines of code to make it, but I think, let me zoom out a little bit, it will look a bit nicer. So what's happening in this plot? We specify the data set. We specify that along the x-axis, we're going to encode the total cigarettes smoked. So that's along this x-axis down here. That's the aesthetic that we're encoding. And then we need to say, what are we plotting on that axis? We're plotting a histogram. And bin width is a really important variable. When you copy this code, if you do not specify bin width to be a relative width to your data, it will result in a really bad plot. You want a plot that has at least 8 or 10 bars in the histogram. Maybe as high as 30, depending on how many observations you have. I also have a geom rug here, which are these individual points at the bottom. They specify where observations actually fell, so that you can have a sense of where they are within this bin. I labeled the x-axis, estimated cigarettes, smoked per month at the bottom, and theme BW, that's a black and white theme. It sort of just changes the background of the, it changes a few style elements of the plot. Okay, let's look at a few more of these. Here's one where the only thing I've changed here is boundary equals 0. So if we look up here, we're looking at estimated cigarettes smoked per month. Those can't be negative, but this first bar contains potentially negative values. It doesn't really make sense for us. But if you specify a boundary equals 0, now the bar starts at 0. So you know that it's basically covering the range of possible values for the data. This is a very good option to use when plotting histogram with non-negative numbers. All right, you can overlay a density plot, which is sort of just a way of smoothing the histogram. The only thing I've added to the plot, I guess there's two things. One is in geohistogram, I've added one element here where I'm specifying that the y-axis is no longer a frequency but a density, meaning that the area of all these histogram bars, if you add up their areas, their height and their width, then that area equals 1. We do that to be on the same scale as the density plot, where this curved shape here, the area under that curve equals 1. And that is approximating the histogram underneath. It's sort of trying to smooth it out. And the adjust here, I believe, is the value that specifies how smooth should you make it. And so you might, if you are interested in smoothing out the histogram to see what the shape is, you might put the adjust in there and try a few values. Make a few larger, make a few smaller, and see if there's a nice shape that seems to summarize the pattern that you see in the data. All right. Shape, center, and spread are the three primary, and outliers. Those four things are going to be the things that you describe a numeric variable's distribution with. So we're going to describe its shape, where its center is, how spread it is, and if there's any outliers. Some of those can be, so if I were to look at this plot and ask what the shape is skewed to the right, or right skewed. The center, because it's skewed, I would probably use the median to say what the center is. Otherwise, if this distribution was more symmetric, I would be more comfortable using the mean as the center of the data. The spread is how spread this is. I'm probably going to use a numeric summary like the interquartile range or the standard deviation to discuss spread. And then are there any outliers? In this case, I would say something like, nearly all the data goes from 0 to about 1,000. There is a small peak above 1,000, and then there's these 3 points. Now, these may be multiple observations at each of these rug points. In fact, it appears that there's several in this small area here just below 2,000. But I would call all of these outliers. It's very unusual for someone to smoke, roughly 2,000 or more cigarettes each month. What would that be per day? I can't even... Oh, so 3,000, if there's 30 days, that would be 100 cigarettes per day. That's 5 packs, because a pack is 20 cigarettes. Okay, so that's sort of what we're looking at. All right, so shape we're going to get from the plot itself. Center is going to be either the median. Okay, so if you do a summary of a numeric variable, you get the mean and the 5-number summary. The minimum, the first quartile, the median, the third quartile, and the maximum. That's the same as the 5-number summary. Okay. You can also pull out specifically just the median, or IQR is the interquartile range. That's the difference between the third quartile and the first quartile. What is, it's telling us the distance of the middle 50% of the data. So that range is 510. So, and I've got some text here that gives an interpretation. So let's look at a final version for this plot. We've decided to have a histogram with the density, boundary equals 0, and we've set the width equal to 100. We have the rug, we have the density over top, and we've done a bunch of labeling. That looks pretty good, and here's the interpretation, and I'll let you read that directly. Looks like I've got a couple. What have I changed here? Bin width of 2. Oh, is this maybe another variable. This is total cigarettes smoked. Okay. This is daily cigarettes smoked. And notice I've changed the bin width down to 2 because the daily cigarettes smoke goes from 0 to 100. With most people smoking, a pack a day is 20, so you get a peak here. Half a pack a day is 10, so you get a peak here. Okay, that sort of makes sense to me. People are rounding to half and full packs. All right, so let's choose a piece of code here for our plot, and I'll just use this last one as a place to get started. Go over to RStudio and find the area for plotting numeric. Here we go. And I remember Control-Alt-I inserts a code chunk. Recall you can get it from code insert chunk there. And I'm going to paste my code in there. And let's choose a variable. Now in your, actually I'm quite happy with the variable that is in my own project. But choose a nice numeric variable. You might try plotting 3 or 4 of these to get a sense of what they look like, and choose one that you feel confident that you can interpret well, you know, if you want to go for the points. And then and here's how I would start. Okay, I'm going to comment out a bunch of stuff, just putting pound signs in front of each row. Okay, and just start with a very basic plot just to get started. I'm going to highlight it and press Control-Enter. I don't recall if this data is still loaded. It is. All right. So there's my basic histogram. If I was unhappy with the bin width, I would modify the bin width. Maybe we can make that 5 cigarettes, and I can run that chunk of code by clicking this play button here. Okay, it's made the bars fatter, right? My previous plot looked like this, and now my new plot looks like this. I sort of like the new plot more. By having too many bars, you're sort of losing the rough shape of it. And this makes sense for cigarettes because people are smoking in fractions of a pack of 20 cigarettes. And so you sort of expect to see some rounding. I think this looks pretty good. This dip here is sort of the gap between people who smoke half a pack and a full pack, right? Maybe there aren't that many people who smoke only 15 cigarettes. Once you get past 10, you might as well go for the whole pack, maybe, is the thinking. All right, when I'm happy with that, let's add in the rug. So I remove the pound sign to bring that line back to life, and I'll run the chunk of code, and we'll see the dots or the dashes appear at the bottom. Now, one comment here, it is creating a line for every observation in the data set. And so if you have got 43,000 observations, there's actually 43,000 lines down here that are plotted. Many of them are plotted on top of each other. You saw maybe the small gap in time when I ran that. Let me comment this out. I'll run the piece of code, watch how fast it goes. Click, boom. And if I put the rug back in, watch how much longer it goes. Click, boom. All right, so that was probably 4 or 5 times as long. So my suggestion here is that the rug is a nice thing to have when you have small samples. So I'm actually going to remove that and not include it in this plot. I'm going to bring everything else back to life. in yours, go ahead and add some nice titles for the axes and so on, and run it. And so here I don't really like this adjust of 1.5. I want something a bit smoother. Let's try 3. Okay, so I increased it and it became more smooth. Let's go up to 4. That sort of looks like a soft way of describing the histogram. I'm sort of happy with that. All right. The rubric for this assignment said for one numeric variable, a histogram or a box plot is plotted with its axis labels and a title. Got that. Interpret the plot and describe the distribution, shape, center, spread, and outliers. Great. So I'll page back down, and here we go. I'm going to remove the creating density plots. We've got a density plot on ours we're happy with. And let's grab a hunk of code for those numeric summaries. So I want, you know what, I'm just going to sort of grab, well, you know what, yeah, okay, I'm going to grab them all and then just delete a bunch of stuff. Okay, I'm going to insert a piece of code, Control-Alt-I, paste it in here. All the output numbers I'm going to get rid of, highlighting and deleting. Okay, it looks like I'm focused on daily cigarettes smoked. So let's focus on that. All right, and if I run that chunk of code, it will bring up the console and give me those numbers down there. All right, the last part is to provide some interpretation. Now, I have an interpretation for mine, but I've got it for another, well, do I have it? I have it for a different subset, right? Because my original project restricted people's ages to 25 years old. So let me grab this. And I'll put the interpretation text down here. And then we'll use that as a starting point. Double underscores are making that bold. Among smokers, no, among, oh, that's true, among smokers, because we don't have numbers of cigarettes for people who are not smoking. The number of cigarettes smoked is right skewed with a median of, how do we calculate that? The median was 15. Is right skewed. I'm going to put some line returns in here to make it a little easier to read. With a median of 15 cigarettes. Oh, I pressed Control Enter and it jumped. Oh, that's interesting. And it jumps down to the next section. I didn't know that. And the IQR, the spread for the distribution, is IQR. Where are you? IQR down here is 14. Okay, new line. There are 3 distinct modes. Well, let's see. Looks like there's a mode down low, people who smoke just a little to about half a pack, people who smoke a full pack, and then there's some sort of outliers. So I would say here, there's probably about 2 modes here. I would say there are 2 distinct modes, or peaks in the distribution. The first between 0 and 10 cigarettes, and the second at 20 full pack. Okay, and the 0 and 10 cigarettes, I'll say half pack and 20. Okay, what else do we have here? The rest of the sentence is about, refers to the previous variable that was being interpreted. There are several outlying values, yes. greater than, I'll say, greater than about 40. Oh, representing 40 cigarettes per day that are possibly overestimates from people responding, right? So this is a survey. It's not like people were keeping a diary of how many cigarettes they were smoking. It's just people are asked to remember how many they were smoking. And so some people said 75 or 80. 80 is 4 packs a day. Okay. 60 is 3 packs a day. Okay, anyway. So there is an interpretation. So what have we talked about? We've talked about the right skewed, that's the shape. Center is the median. The spread is the IQR, right? I guess we could put in right skewed, that's the shape. And then outlying values, those are the outliers. Okay, so we've covered all 4 pieces there. That looks pretty good. Let's knit this and take a look at the output. And if we're happy, we'll end the video and go on to the next. The other nice thing about removing the rug, which took a lot of time in creating the plot, is that every time you compile the document, you have to wait those extra couple seconds. And over your lifetime in this class, that's going to feel like a lot. All right, so here is class 6. I'm going to go down to numeric variables and zoom in a bit. All right, and are we happy with the output? We've got our plot, looks nice. We've got some numerical summaries that helped us when we wrote our interpretation. And if we go back and just check out the rubric and make sure we're satisfied all the components, one numerical variable, histogram or box plot is plotted with axis labeled in title, interpret the plot, describe the distribution. Perfect. That's very good. I want to mention one detail. There will be cases when you are unhappy with the aspect ratio of your plot. Okay, so we're around line 600. We'll come back here in a moment. I'm going to jump up to the top. I press Control Home, and I'm going to zoom down to the first code chunk, which is pretty near the top, right here. Global Code Options. Okay, there are some options here: figure height and figure width. I just want to show you an example of modifying that and how it affects the output, and then we'll end the video. So let's zoom down to 600, line 600. Here we go. And so here is the way the plot looks. Sorry guys, here we go. Okay, it's 4 inches tall and 6 inches wide. That works beautifully for this particular plot, in my opinion. But what if we wanted something taller? Okay, so what if we wanted a figure height of 6 and figure width of 4? We can do that. These are in inches, roughly, and for how it appears on your screen at 72 dots per inch. By the way, if you run this here, it's just going to create the same plot. The plot that appears in the window on the right is sized based on how you size this window. So you can't really get a sense of how this takes effect unless you knit the document. So I've clicked knit. It's going through. When it goes to create this plot in the HTML file, it's going to refer to these figure height and width parameters to create a plot that corresponds now to that size. So now we've got a really tall figure. Okay, so now you've got some additional control for how your output looks. Notice that the title gets cut off because it's not wide enough. Okay, so what I'll do after I stop the video is I'm going to undo those height and width code chunk options because it looked better before. But yours might look better when it's bigger. You can make the whole thing bigger. I would say about 10 inches square is about as large as you want to make a plot. But sometimes bigger is better, and sometimes smaller is better. My suggestion is to try a couple and and try to keep it simple. All right. See you in the next one.